friends, myself Pratik. In this session we are going to discuss naive-Bayes classifier. Let us start this session. Naive-Bayes classifier is based on Bayes theorem, and Bayes theorem was given by Thomas Bayes in mid of 18th century. So it's very interesting to know that the theorem which was given by a scientist in 18th century is nowadays used in machine learning for building classifier, and the classifier which is based on Bayes theorem is known as naive-Bayes classifier. This theorem is based on the hypothesis that the given data sample belongs to a certain class. Actually, in this case we calculate the probability for the given hypothesis to be true. And according to Bayes theorem, we calculate the conditional probability of A given B. It means that B has already been occurred, and what is the probability that next event is A. So here we calculate the probability of occurrence of A when B is given, or it is simply called as A given B. And in order to calculate A given B probability, we can make the use of Bayes theorem. It states that probability of A given B is equal to probability of B given A multiplied by probability of A divided by probability of B. So this is the Bayes theorem which is used to calculate the probability of a hypothesis to be true. In order to understand this concept further, that how we can apply this theorem in building our classifier, let us consider this case. Here I am representing the data of a company. The data points shown in the red are those people who commute to office on four-wheeler, while data points on blue are those points who commute to office on two-wheeler. And all these points are scattered on the basis of salary and age of the employee. The task of the classifier is to predict this new data point, who is actually a new joining to this company, and we have to predict whether this particular employee will commute on two-wheeler or on four-wheeler based on his salary and age. So it means that we have to build a classifier to predict whether this new data point or new joining will commute to office by two-wheeler or four-wheeler based on his age and salary. In this case, we are calling this new data point as X. According to Bayes theorem, we have to find out the probability of two-wheeler given X. It means we want to find out the probability that person X will commute to office with two-wheeler. We will also calculating the probability of four-wheeler given X, that X has already been occurred, and what is the probability that he will be commuting with four-wheeler. Actually, you can consider these two as hypotheses. One hypothesis is that this new employee will commute to office on two-wheeler, and second hypothesis is that this new data point X will commute to office on four-wheeler. So we have to check the probabilities of both of these hypotheses. So we will be calculating the probability of two-wheeler given X and probability of four-wheeler given X. And based on the value of these probabilities, we will be making our prediction. So if the probability of two-wheeler given X is more than probability of four-wheeler given X, then the predicted class will be two-wheeler. Otherwise, the predicted class will be four-wheeler. So this way we can apply Bayes theorem to perform classification for this data set. And in order to understand Bayes theorem in a better way, let us consider this example. Here we are considering a factory. This factory is using two machines to manufacture these screws. Some of these screws are manufactured by machine M1, while some are manufactured by machine M2. Let's suppose total number of screws manufactured in 1 hour by the factory is 40. And out of these 40, the number of screws manufactured by machine M1 in 1 hour is 15, while remaining 25 screws are manufactured by machine M2. So in this way, the probability of screw manufactured by machine M1 is 15 divided by 40, which is 0.375. And same way, the probability of screw manufactured by machine M2 is 25 divided by 40, which is 0.625. These machines will also produce screws which are defected. Let's suppose the probability of defected screw produced by the factory is 1%, it is 0.001. In this scenario, machine M1 and M2 each have equal probability of producing defective screws. It means that 50% of defective screws are produced by machine M1 and remaining 50% are produced by machine M2. Now let us find out the probability of defective screws produced by machine M1. Now, in order to represent this probability, we have to use conditional probability. Let's read this point again. Probability of the defective screws produced by machine M1. In this case, we know that the screw is defective, but now we have to find out its probability that it is produced by machine M1. So we can represent this by using conditional probability, and it can be represented by M1 given defected. So we know that the screw is defected, but we have to find out that if it is defected, then what is the probability that it belongs to M1. And as mentioned here, that we have a 50% probability that it belongs to M1. So this will be 0.5. The same way, the probability of defective screws from machine M2 will be P of M2 given defected. So we know that the screw is defected and we want to check that whether it belongs to M2 or not, and then its probability is 50%, which is 0.5. So all these are the given probabilities in this example. And the question is, we have to find out the probability that the screw is defective if it is produced by M2. So we want to calculate this value, which is the probability that screw is defective if it is produced by M2. Now, can you give a thought to represent this value according to conditional probability? Again, read this point. What is the probability that screw is defective if it is produced by M2? Now we know that it is produced by M2. Now we have to find out that whether it will be defected or not. So we can represent this by using conditional probability, and we can represent this like this: defected given M2. So we know that it is produced by M2. So defected given M2. So M2 is given, but we have to find out the probability that it will be defected. So in this case, the problem statement is to find out this value of conditional probability. And in order to calculate this value, we can make the use of Bayes theorem. And we know that in case of Bayes theorem, the probability of A given B is equal to probability of B given A multiplied by probability of A divided by probability of B. So if we can fit all these values for probability of defected given M2, then the Bayes theorem will look like this. It will be probability of M2 given defected multiplied by probability of defected divided by probability of M2. And we have all these values in our previous calculations. So we have the probability of M2 as 0.625. The probability of defected is 0.01, and probability of M2 given defected is 0.5. So let's put all these values here. Probability of M2 is 0.625, probability of defected is 0.01, while probability of M2 given defected is 0.5. So if I put all these values, I will get 0.008. It means we have a 0.8% chance that screw will be defective if it is produced by machine M2. We can further prove this by considering actual numbers. So let's suppose a factory is producing 1000 pieces of screws. Then according to the discussion we have, the number of screws produced by machine M1 will be probability of machine M1 multiplied by 1000 in this case. Since the probability that screw is manufactured by machine 1 is 0.375, so 375 screws would be produced by machine M1, while the number of screws produced by M2 will be probability of M2 into 1000, so which is 0.625 multiplied by 1000, it will be 625. So out of 1375 are manufactured by machine M1, while 625 are manufactured by machine M2. Now based on that, we can find out the number of defective pieces. Since we know that the probability of defective pieces produced by the factory is 1%, which is 0.01 in terms of probabilities, which is multiplied by 1000 give us 10. So it means there are 10 defective pieces out of 1000 pieces. And each machine has a 50% probability to produce defective piece. So we have total 10 defective piece. It means that 5 defective piece will be produced by machine M1, while 5 will be produced by machine M2. So in this case, we can calculate the percentage of defective piece produced by machine M2. So number of defective piece produced by M2, it is 5, and total number of pieces produced by M2 are 625. So 5 divided by 625 give us a percentage as 0.8%, or the probability value as 0.008. This is the same value which we have calculated by using the Bayes theorem. So this clearly states that Bayes theorem is very useful to find out the conditional probabilities of X given Y or A given B. And in this case, we have calculated the conditional probability of defected given M2. It means we have proved this by considering actual numbers. I think that this example has given you a fair idea that how Bayes theorem is useful to find out conditional probability and how we can apply it in real practical examples. In next session, we will be applying naive-Bayes classifier over this data set to make predictions for this new data point, which is actually a new joinee of a company, and we will be predicting whether this new joinee will be commuting to office on two-wheeler or on four-wheeler on the basis of his salary and age. We will be doing this in our next session. Thanks for watching this video.